Hey everyone, welcome back to the ThunderCipher. So today we are going to talk about something really interesting and honestly something that most developer, even the security peoples completely ignore until it's too late. We are talking about software supply chain failure. Yeah, which is ranked at the number 3 in on the OWASP top 10 list for 2025. Yeah, wait. Now, before you click away things, supply chain sounds boring. Trust me. Stay with me for the next few minutes because by the end of this video, you are going to realize that this vulnerability is responsible for some of the biggest hack in the recent history. Yeah, we are talking about the billion-dollar theft, government agencies getting compromised, and millions of developers unknowingly shipping malwares to their users. So, without wasting time, let's get into it. Alright, first thing first, what even is an OWASP? OWASP basically stands for Open Web Application Security Project. Yeah, just think it like an global community of the security researchers or an experts who get together and say, hey, what are the most dangerous and the most common security mistake happening in the software world today? Like they are discussing about this. After the long deep discussion, they publish a list. The list name is the OWASP Top 10, which is basically the top 10 most critical web security risks that developers and the companies need to worry about or must have the information about that vulnerabilities. Now the important things is this is not just a common some random list. For this 2025 edition, they analyzed over lakhs of CVs. CVs stand for common vulnerabilities and exposure, basically documenting security flaws, and they survey over 500 plus companies across the world. So when OWASP says something is dangerous, you must listen. And you can see in 2025 they are saying software supply chain failure is the number three biggest threat. If you compare this with the previous list, which was 2021 list, it is one of the newest entries, which basically tells how fast these threats are growing. Let me just show you the full OBAS top 10 for 2025 really quickly. As you can see, the broken access control is at number 1 position, cryptographic failure at the number 2 position, then right at there, number 3, software supply chain failure. And here is something interesting. Like in the 2021 edition of this list, there was a category called vulnerable and outdated components at the number 6 position. Like this is basically telling about if you have any old or broken libraries in your code, that is dangerous in a simple term. But in 2025, they did not just keep that, they completely evolved it into something much bigger. Supply chain failure goes way beyond just using the outdated libraries. It covers the entire journey of how software is built, packaged, and delivered. And that is the fact behind it that it jumped from number 6th position to the number 3rd position in 2025. That tells you the everything you need to know about how serious this has become. Okay, so now the biggest question is what exactly is software supply chain? So let me just give you a real world example so it will be easy to understand. Just think about how chocolate bars are made. Like any chocolate bar, the company doesn't grow the cocoa powder themselves. They just buy the cocoa from the farmers and sugar from any other companies or any other suppliers, and they give the contract of packaging to some other factories and so on. Every single ingredient comes from somewhere else, and the final products that reaches you depends on every single one of those suppliers being trustworthy and safe. And the software supply chain exactly works in the same way. When the developer writes an application, they do not write every single piece of code by themselves. That will take forever. Instead of that, they use the third parties, libraries, and the packages, basically the pre written codes that perform some basic task like sending emails, or for example, I'm just telling handling payments or processing images, like basic tasks like this. They also uses the build tools to all compile and package their codes. They uses a CI/CD pipelines, which are automated systems that test and deploy the codes. They pulls the container images from the registrations like Doc Hub, and they push the updates through the update mechanisms. All of these things together, the code, the tool, the pipelines, the registration, the update system, the entire chain of the components is our software supply chain. And here is the scary part. Every single link in this chain is a potential attack surface. Like if any one of those steps, not your code, but the tools or the dependencies which you rely on, they can sneak malicious code all the way into your final product, and you will never even know what actually happened. And that is what the make the supply chain attack so dangerous. You can write the perfect code and still get hacked because the attack did not come through your code. It came through something you trusted. Now you might be asking, okay, this sounds bad, but is it really that common? Like, is it really worth the third position? Like, if you guys have this kind of questions in your mind, then let me just give you some numbers. When OWASP did their community survey, asking thousands of security professionals what they were most worried about, 50% response voted as supply chain as their number one concern. Like half of the community means that is massive number of peoples. On the top of that, supply chain failure has the highest average weighted impact score out of all that top 10 categories. What does that mean? It means when a supply chain attack happens, the damage it causes is bigger than almost any other types of attack. And if you have a look at the bar chart comparing category, you can see that the exploit and the impact score for supply chain are the very top. It is way above than the broken access control and way above than cryptographic failure also. And the reason behind it is very simple. With most of the attack, you just compromise a single application or one application. With an supply chain attack, you can compromise a thousands or a millions of applications all at once because they are all using the same compromise components. Like if there is a one compromised component and most of the applications are using the same compromised application or the components, so if we got a vulnerability or the weaknesses in a particular one website application, and it leads to millions of applications are getting compromised at once because they are using almost same compromised component, which is basically like one attack, millions of victims. That is what the power of supply chain attack can do. All right, let me just show you and what this actually look like in a real world example. I will just take a few scenario based examples, real world attacks that happened. And the number one attack is the SolarWind attack, which basically take place between the 2019 to 20. Like SolarWind was basically a company. They actually made a IT monitoring software called Orion, and most of the companies and the government agencies used it. We are talking NASA, the Pentagon, major banks, and the Fortune 500 plus companies were using this. So what actually hacker does is a government backed hacking group managed to get into the SolarWind build system. So here the build system is an internal tool that packages and compiles the software before it getting shipped to the customer. Like in software, developer writes the code all day, thousands of lines of it, but the raw code cannot just give handed directly to the customer. It need to go through lot of process. It get compiled, test, package, and turn into a neat installer or updated files. That process and the tools that do it, it is basically called build system. So think of it is in this way: the build system is a factory, like the raw code goes in and the final software product comes out. So what attacker does is they injected a backdoor into the software, hidden pieces of the malicious code, which they named it as Sunburst. And then after injecting the malicious code, the SolarWind did exactly what they were supposed to do. They pushed out an routine software update to all their customers, and every single customer who installed that update unknowingly installed the backdoor in their system. Like over 18,000 organizations were affected. Government system were compromised for months before anyone noticing. This was an arguable but the biggest hack in the US history. So now let us discuss about one of the similar attack that happens recently, which was Bybite hack. And Bybite is one of the biggest cryptocurrency exchange in the world. Like in early 2025, attackers stolen 1.5 billion dollars from them. This that is the largest crypto theft ever recorded in the history. So what does attacker do to break into the system? Not by breaking the Bitcoin's own system, they compromise the front-end code of the Safe Wallet, a popular crypto wallet software that Bitbyte was using internally. By corrupting that one tool, they were able to manipulate how Bitbyte's multiple signature wallet worked and drained over $1.5 billion of money from crypto. And this is one of the supply chain attack, perfect execution of the attack. So the number third attack was Cyanide NPM worm, which taken place in 2025 itself. This was one of the terrifying from technical perspective. Like NPM is a package register for JavaScript developers. It is where millions of developers download code packages every day. In 2005, researchers discovered that what they called for the first ever self-propagating npm worm, a malicious package that once installed would automatically infect other packages on the system, which would infect more packages, spreading like a virus. Over 500 packages version were infected before it was shut down. This was literally a worm like the classic computer worm from the early days of the internet, but living inside a modern software supply chain. Like if you observe the pattern, like each of these attacks has one thing is very common. Like the actual target code was completely fine. The attacker went through supply chain method. So now let us discuss how does this attacks actually happens. Now you understand what is supply chain attack, how devastating they can be, but how attacker actually pull this off. Let me just talk you through one of the six most common attack vectors that attackers use to pull this software supply chain attack. The first one is the dependency confusion. Here is a clear trick that attackers use. Like most of the companies have then internal packages, like they will write their own code libraries they wrote themselves for internal use with company name, like for example company internal utensils. They will store this on their private server. An attacker finds out the name of the private packages, sometimes just by looking at an error or some open source configuration files that are available. Then they upload a malicious public packages with an exact same name to npm or py, the public package registers. And now when your build system runs, it checks both public and private sources. If and many systems are configured to prefer the higher versions of the number, so the attacker just upload a malicious package with a higher version number, like something like 9.9, and your built-in system pulls their malicious package instead of your safe private one. So you did not do anything wrong. Your build up system did exactly what it was to told, and it still got hacked. So the number two is typo costing. This is one of the simple but most effective. Like just imagine you are a developer, you are just want to install a packages, like you want to install a package called request. You are typing type install request, but instead of typing request, you just misplaced a single character, and you just in a hurry you just hit it enter. An attacker has already created a malicious package called something called request with same typo and publishes it into PYPI. And congratulations, you just installed a malware. The attacker literally sits and registers hundreds of common typos of popular packages name, and developer who type fastly and who are tired, who are multitasking, make these mistakes all the time. So the number three is compromise maintainer. This is how SolarWind attack category of attacks works at a smaller scale. and open source packages that millions of users might be maintained by just one or two developers in their spare time. An attacker basically targets the developer account. Maybe they find a reused password in the data breach, or maybe they phishing them using a fake emails. They get access to the developer npm or py account, and then they push us a new version of the package with malicious code hidden inside. Every developer who updates their new version, or they could be a millions of them, gets the malware, and they have literally no reason to suspect anything because the update came from the official maintainer account. And the fourth one is CI/CD pipeline injection. Like CI/CD pipeline is an automated system that runs your task, builds your code, and deploy it to the production. Like it can read your entire code base, it can access your production server, it holds your API keys and secrets. Like if an attacker can inject malicious code into your pipelines through a compromised build scripts, a backdoor GitHub actions, or a stolen pipeline credentials, they can do anything. Steal your secrets, modify your final build project, deploy the backdoor to your server. Literally, they can do anything. And because the pipelines run automatically on every push, the attacker can do it all this very silently and every single time you deploy. The number three is tampered artifact registries. So this kind of attacks happens when you build a Docker container or a compile a binary. You often pull some basic images from the public registers like Docker Hub. What attacker can do here is an attacker can upload a malicious container image with a name very similar to the legitimate one, like Ubuntu 22.04 instead of 22, like use hyphen instead of colon in between the name and the version. And the developer who are not being very careful will pull the wrong one, or in more sophisticated attack they can compromise the registry itself and replace legitimate image with backdoor ones. And the next is malicious IDE extension. Like this is one of the underrated. VS Code has thousands of extensions. JetBrains has a marketplace. Most developer install extension without thinking too much about it, but the extension has a deep access through your development environment. It can literally read your codes, each and every file which is open. It can see your environment variables. It can literally send codes to external servers silently. There have been multiple document cases of a malicious VS Code extension stealing source code from API source code and the API's keys from the developers. Like I know one of the extension, you just check out that. The extension was user switch agent or user agent switch, something like that. You just check that. Like it is used to completely transfer your browser data. All right. Now the most important part, how do you defend yourself? Let me just give you the 6 ways or 6 things you can implement. The first one is generate an software bill of material with every build. So like every time you build a software, generates a software bill of materials called as SBOM. Tools like Snap, Cyclone DX, SPDX can do this automatically. Your SBOM should list every component, every version, and every license you are using. Like this does two things. It gives you the visibility into what is in your software, and it gives you something to audit when a new vulnerabilities is disclosed. Instead of wondering are we affected, you can just check your SBOM, which refers to software bill of materials, in seconds. And the number two is do continuous SCA scan. Like here, SCA stands for software composite analysis. Tools like OWASP dependency check will automatically scans your dependencies every time you push your code and flags everything or anything that has known vulnerabilities. And the keyword is continuous, not just once. When you set up a project, new vulnerabilities are disclosed every day, so your scanning needs to be ongoing. And the third tip is like pin your dependency and verify them with hashes. Instead of writing the request greater than or equal to 2.0 in your requirement files, which means give me any versions which are greater than 2 point or higher than that, pin that an exact versions or verify it with cryptographic hashes. Like this basically tells give me the exact version and verify that the file I receive that matches with the specific hash values. If someone has tampered with the packages, that hashes will not matches. So at that time you can easily identify that. And never ever use the latest as your version. And the fourth one is artifact signing. Sixstore is an open source tool. Like if anyone who downloads your software can verify that it is built by you and it has not been tampered with. And this is like a wax seal on a letter. If a seal is broken, you know it, someone has opened it. And the fifth one is harden your CI CD pipelines. Like treat your pipelines like a production system because it is enables the two-factor authentication on all the systems that has a pipeline access. Use the principle of least privilege. Each part of pipeline should only have an access to exactly what it needs and nothing more. And use the peripheral runners, like build environments that are created fresh for each job and destroyed immediately after. And protect your main branch which requires reviews, and store all secrets in a dedicated secret manager like HashiCorp's wallets or AWS secret manager, never in a plain text form or in a plain text configuration files. And the last is the practice good secret hygiene, like rotating your credentials regularly, using short-lived token instead of long-lived API keys wherever possible. Never store the secrets in your repository, not even the private one. Use tools like Gitly to scan your repository for accidentally committed secrets. And if a secret is exposed, rotate it immediately. Do not wait. Okay, I want to take a moment here, give you the big perspective on why this matters so much. Think about the web security was 10-15 years ago. The big threat were there was SQL injection, where attackers types malicious SQL into your login forms uh, and dump your database. Or maybe cross-site scripting, where they inject malicious JavaScript into your web page. These are the code level bugs the attackers is exploiting a mistake you made in your code. But look at the attackers we just talked about, SolarWinds, Bitbytes, the NPM worm. In none of these cases did the attacker finds the bug in the victim's own code. The victim code was completely fine. The developer did not make a single mistake. The attacker came through the ecosystem around the code. This was the big shift that the 2025 OWASP top 10 is recognizing. Security is no longer just about writing the bug-free code. It is about securing the entire life cycle of your software, from the dependencies you choose to the tools you build with the to the pipelines deploys through to the way you verify and the sign up what you have shipped. The thread model has changed. If your security practices has not changed yet, you are already behind. All right, before we wrap up, let me give you some four most important things to remember from this video. Number 1, trust nothing blindly. Every package you install, every updates you apply, every container image you pull, verify it. Like where did it came from, who signed it, does the hash matches. Blind trust in your supply chain is a vulnerability in itself. Number 2, software bill of materials is non-negotiable. If you are building a software professional in 2025, whether for the company or for your own project or for some clients, you need an S-bomb. You need to know exactly what is inside of your software at all the time, no exception. And the number 3, secure the pipelines, not just the product. Your CI/CD pipelines is one of the most powerful and the most targeted system in your infrastructure. It deserves the same level of security attention as your production server, maybe even more. And the number 4, developers are now primary target. This is uncomfortable reality of the modern society. Attackers are not just going after your web application anymore. They are going after the developer themselves, like through using the fake extensions, compromised tools, malicious package. Your developer environment is an attack surface to protect it accordingly. So this was all pretty much about software supply chain failure. If you have any other doubts related to this, just let me know in the comment section. Do not forget to like, share and subscribe. Thank you guys.